Hey, it's section 8.1, the Pythagorean Theorem and its Converse by Mr. Moulton. The objective today is to use Pythagorean Theorem and its Converse, and a pretty cool picture here. Some random thing from the PowerPoint, but I don't know what the heck. Alright, anyway, Theorem 8.1, Pythagorean Theorem. Basically, a squared plus b squared equals c squared. So in a right triangle, the sum of the square of the lengths of the legs is equal to the square of the hypotenuse. A squared plus b squared equals c squared. And again, c is always the hypotenuse. Pythagorean triple. This is a set of non-zero whole numbers. Whole numbers is the key. A, b, and c, that makes a squared plus b squared equals c squared. True. So here are some common Pythagorean triples. 3, 4, and 5. So 3 squared is 9, 4 squared is 16. Those added together equal 25, which is equal to 5 squared, which is 25. Now notice 3, 4, and 5 are all whole numbers. All whole numbers, 5, 12, 13. Sometimes we won't have that, so they wouldn't be a Pythagorean triple, but these ones are Pythagorean triples. Alright, so here's two examples. Find the value of the missing length using Pythagorean theorem. So 20 squared plus 21 squared equals x squared. That's how we would set that one up, and we will get x equals 29. And I would practice this one if you have a piece of paper. I would definitely practice and write down some of these examples. So here we have 8 squared plus x squared equals 20 squared. So this is a little bit tricky because normally we're solving for the hypotenuse, but not in this one. So you could pause the video, solve for it, and you get this. Alright, next is the converse of the Pythagorean theorem. So basically, if a squared plus b squared equals c squared, you do that. Then the triangle is a right triangle. So we don't know initially if it's a right triangle, but you do this, and that's true, then it's a right triangle. Alright, are the following right triangles? So you could solve for this. Again, pause your video. See if this 13 squared plus 84 squared equals 85 squared. And yes, it does. So therefore, it is a right triangle by this theorem. Do the same thing over here. See if this squared, 20 squared, plus 21 squared equals 28 squared. For this one, it does not equal it. Therefore, no, it is not a right triangle. Alright, next, we're going to have ones where it does not equal the same thing. So maybe c squared is greater. If c squared is greater, you could kind of see here, it's going to open up the triangle more. Therefore, the triangle will be obtuse. Obtuse. Alright, we're obviously going to have another theorem where c squared is less than a squared plus b squared. If it is less than, like this one, then the triangle is acute. So you can see it, if this side is squared is less than, it's going to close this out a little bit more than the other one. Alright, so here we're going to classify with examples. We have triangle with sides 6, 11, and 14. How can you classify the triangle? Well, let's do 6 squared plus 11 squared equals 14 squared. If the 14 squared is greater than those squared, it'll be obtuse. If not, it'll be acute if it's less than. So this one is obtuse. This one, here I'm going to go back. It doesn't show this example right away. So pause it. Pause it if you saw that. And you'll get acute, not a pretty triangle, but an acute triangle. My bad. Alright, so here's just an application problem at a park. We want to know the distance across the little pond here that people will paddle. We have 350 meters down, 250 across. Simple application problem that you can actually use to measure that distance. So you go through, you could pause the video, and if you solve for the total meters, you will get 430.11 meters. So a little bit more than the 1 lap around a track. How about that? That's all for today. Thank you for listening. Have a great day.